Welcome to chapter 8. In this chapter, we'll cover what's called arrays. What is array? Array is part of a data structure. It's just a way to organize data. It makes it easier to access. Instead of initializing data one at a time, you can initialize it all at the same time. It can hold multiple values. Accessing array elements is another thing we'll discuss. Inputting and displaying array contents. Array initialization, processing array contents using parallel arrays. The typedef statement, arrays as function argument, two-dimensional arrays, arrays with 3 or more dimensions, vectors, arrays of objects. Array, it's a variable that can store multiple values of the same type. In the past, we have assigned variables to just one variable. But here, array is a variable that can store multiple values of the same type. Values are stored in a consecutive memory locations, and we use the brackets operator. So declared using the bracket operator. So here is a way to declare constant integer is size 5, and then integer tests, and then whatever the size is. It's one way of doing it. Array storage in memory. So the definition is here you can say int test is size, and then allocates memory allocation allocates the following memory. And the way it allocates is it uses indexes, and the first index would be 0, the second one would be 1, and so forth. So elements of 0, 1, 2, 3, 4, and so forth. So let's say in the case of if we were trying to create an array that holds the number of days. If it starts with 0, we will say what? Array. No, if we're trying to hold it 7 days a week, it would be what? Right? So we would have it as, and then if we wanted to print, let's say, if Sunday was the first one and then Saturday was the last one, and if we wanted to print Saturday, how would we access Saturday? It would be the 6th element, right? Okay. So the array size would be 7, but the elements inside the index 0 all the way to index is 6. So to print Saturday, it would be array 6. Okay. And the same thing with if we wanted to store the number of months in a year, the size it would be 12. But if you wanted to access December, it would be 11 index. Okay. So in the definition, int tests is size. Int is the data type of the array element. So tests is the name of the array. Okay. And is size, or in this size, is the size declarator. It shows the number of elements in the array. The size of an array is the number of bytes allocated for it. So number of elements times the bytes needed for each element. So some terminology. So assume that int uses 4 bytes and double uses 8 bytes. So when you declare it like this, so int test is size holds 5 integer arrays, and it occupies 20 bytes. So double volume holds 10 doubles, array occupies 80 bytes. So each array element has a subscript used to access the element. So subscripts start at 0, so 0, 1, 2, 3, 4, and so forth. So in the case of for the week, 7 days a week, it would be 0 through 6. And in the case of the month, it would be 0 through 11, and so forth. Okay. So array elements accessed by array name and subscripts can be used as a regular variable. So here you have tests 0 through 4, even though you have 5 elements there. So test 0 will be 79, C out test 0, and then sin test 1, and so forth. Okay, test 4, okay, so equals test 0 plus test 1. Okay, but you can, let's say, C out tests illegal due to missing subscript. We need to know which one do you want to print. Okay. C out and cin can be used to display values from and store values into an array. So here you have constant integer is size equal to 5, and then int test equals is size. You can do this, or you can just put the 5 right here. That's another way of doing it. Okay. And then you can have cout, enter the first test score, and then the first one, sin will be the first one, and so forth. Array subscripts can be an integer, a constant, integer variable, or integer expression. So here are some examples. So you can say sin test3, cout test1. This is an integer variable, and this can be an expression, test I plus j. Now, to access each element of an array, you have to use a loop. So let the loop control variable be the array subscript, and a different array element will be referenced each time through the loop. So you can say for I equal to 0, and then I less than 5, I plus plus. And assuming that you have declared the variable I. So you have to say int I. If you didn't say that int I here, you would get an error here. Or you can say the int here for int I equal to 0, then I less than 5, then I plus plus. Okay. So getting array data from a file. So constant int is size is 5. Cells is size. Again, this author likes to use it like that. Again, you could have just put that number in there. If a stream data file, this is reading a file, data file.open, cells that you're writing into an external file. You're trying to open an external file, and if data file doesn't exist, then display error of opening that file. Else input daily cells, and this is populating. And this is what I was talking about. You need to declare that variable day. So you say int day here equal to 0, day less than whatever the size is, or you can say less than 5 if you put 5 in there, then day plus plus to increment it. Okay? And then at the end, you have to make sure that you close the data.file.close so that there isn't any data leak. No bound checking, so there are no checks in C++ that an array subscript is in range. So an invalid array subscript can cause a program to override other memory. You have this in Java and also in Python. Okay, Python supports that. So example, you say constant int is size equals 3, int I equal to 4, int num is size, then num I equals 25. Off by 1 errors. So most often occur when a program accesses data one position beyond the end of an array, or misses the first or last element of an array. So don't confuse the ordinal number of an array element, first, second, third, with the subscript of 0, 1, 2. Don't get confused with that. Okay. An array initialization, so it can be initialized during the program execution with assignment statements. So you can say test 0 equals 79, test 1 equals 82, but this can be time consuming. You can initialize an array definition with an initialization list. So here, if you say 5, again, you can just say 5 here, like I said, and here you can populate. Instead of doing 1 by 1 like that, you can just use the brace 79, 82, 91, and so forth. Okay, set an element 0 or 1. So you can choose to declare arrays to be 1 larger than needed. So this allows you to use the element with subscript 1 as the first element, and so on. And you may minimize off by 1 error. So the elements with the subscript 0 is not used. So this is the most often done when working with ordered data. So months of the year or the days of the week. You can have partial array initialization. So if an array is initialized as the definition with fewer values than the size declarator of the array, so remaining elements will be set to 0 or the empty string. Okay. So here you have int test is size equals 79. 82, and then the rest will be 0. Initial values used in order cannot skip over elements to initialize a non-contiguous range, so cannot have more values in initialization list than the declared size of the array. You can have less, but you cannot have more. Okay. You can determine an array size by the size of the initialization list. Okay. So it must be either use an array size declarator or initialization list when an array is defined. You can use some of the examples that's covered in the book. Array elements can be treated as an ordinary variable of the same type as the array, so used in arithmetic operations in relational expression. You can have an example here, array, third one, greater than or equal to 1,000, interest equals principal of the position times the interest rate, else interest equals that, and interest rate too. Use an increment and decrement operator with array elements. When using plus plus or minus minus operators, don't confuse the elements with the subscript. So here you have test I equals plus plus is different from the test I. You say increment I, but has no effect on the test itself. Cannot copy with an assignment statement. Okay, so if you say test2 equals test1, this won't work. It has to be whatever the subscript is or the index. You can use a loop to copy elements by element. So integer index equal to 0, less than the size, index plus plus. And then here you can say test2, whatever the index is, equal to tests in index. Two arrays equal, like copying cannot compare in a single expression. So if test2 equals test1, can do that. However, you can use a loop, okay, and then use a boolean equal, and then while equal and index less than size, then we say if this is not equal to that. Okay. Sum average of an array elements. Use a simple loop to add together an array elements. Float, average, sum, and we will use an example of this. So we'll say for int tnum equals tnum less than is size tnum plus plus, then sum, and he's using augmented operator, so sum plus equal tests, and then whatever that is, the numbers that have been put in. One summed average can be computed also. You can use that average for sum divided by is size. Largest array element, use a loop to examine each element and find the largest element. So here you have integer largest equals test equal to 0, then for int tnum equals 1, tnum less than the size. If tests tnum is greater than the largest equals test tnum, and then you can print that out. Okay, so a similar algorithm you can use at page. Look at page 525, problems 8 to 10. You can have partially filled arrays, so the exact amount of data and therefore array size may not be known when a program is written. So a programmer makes the best estimate for a maximum amount of data size arrays according. A sentinel value can be used to indicate the end of a data. We discussed this before, right? Or maybe it was Python class. What is a sentinel? And that's different from what you have been entering, right? We discussed it in the case when we were doing loops. Okay, so it's basically to say the program to end it. Okay, in the case of, I think when we were in a Python class, in your assignments, you have to ask, is there another customer, right? And you have to type yes or no. Or you can say add, or you can collect a number of positive numbers, and then to end it, enter a negative number. Okay, so the opposite of what you have been. So that's a way. That's basically a sentinel to end a program. So a program must also keep track of how many array elements are actually used. So using array versus using simple variables. So an array is probably not needed if the input data is only processed once. So find the sum or average of a set of numbers. Find the largest or smallest of a set of values. So if the input data must be processed more than once, an array is probably a good idea. And calculate the average, then determine and display which values are above the average and which are below the average. So you have C-string and string objects can be processed using array name, entire string at once, or one element at a time by using a subscript. So string city, you have then enter city name, and then you can read that city, and then Salem. So in each variable would be a 1. Each value would be assigned on index. You can have parallel arrays, 2 or more arrays that contain related data. Subscript is used to relate arrays. Elements, the same subscripts are related, so the arrays do not have to hold data of the same type. Okay, parallel arrays, once you initialize or state the size that you want, you can say string name in size to hold the student name, float average to hold the course average, char grade to hold the course grade. All right, and then you can use the loop, integer I equal to 0, and then do the loop of the student name, the average, and so forth. You can look at those examples covered here. The typedef statement creates an alias for simple or structured data type, and the format is typedef, existing type name, and then a new name. So you can say typedef unassign int, uint, and then doing the array of the unassigned integer. It's used to make a code more readable, and it can be used to create alias for an array of a particular type. Okay, so here you can say typedef int array months, create 2 of these arrays, so highest temperature and lowest temperature. I think we had an assignment that you had to do, or maybe it was one of the exam questions in the previous course that we had, right? So passing a single array element to a function is no different than passing a regular variable of the data type function. It doesn't need to know that the value is received is coming from an array. So you can say display value score I. You're doing a call here, and then void display value. This would be the function when you create it, and then this is when you call it. Passing an entire array. So to define a function that has an array parameter, use the empty operator or bracket to indicate the array argument. To pass an array to a function, just use the array name. So here you have the function prototype void show score, and then this is the function header void show score int test. Passing an entire array, so use the array name without any brackets as the argument. You can also pass the array size to the function. The function knows how many elements to process. So here you have show scores tests and then 5, and then this is the function itself. So void show score int, and then here you're saying the size. Show scores int, and then the array, and then int size will be the header. Using typedef with a passed array, you can use it to simplify function prototype and heading. Typedef int array, and then it will be the prototype, and then it will be the header. Modifying arrays in functions. Array parameters in a function are similar to reference variables. So changes made to an array in a function are made to the actual array in the calling function. You must be careful that an array is not inadvertently changed by a function. So you can use a const keyword in prototype and header to prevent change. When you say constant, it means that you're avoiding for any type of change, right? You can have two-dimensional arrays, kind of like what you see in Excel. So you can define one array for multiple set of data, like a table in a spreadsheet. Use two-size declaration in definition, something like that. Int exams 4 and 3. So you can hold the rows, let's say student names, and then number of columns, let's say student scores. Okay, so similar to what I just said there, I guess. And then you would use two subscripts to access an element. Initialization at the definition. Two-dimensional arrays are initialized row by row, so int exams 2, and then here you're passing it. Okay. You cannot omit the braces. You have to be consistent. Use array name and number of columns as an argument in a function call. So use the empty bracket for row and a size declarator for column in the prototype and the header. So here you would say void get exams int, and then number of columns, and then int. So here you have the int, the rows, and then the columns. Okay, the header void get exams int exams, okay, the rows and then the columns. Can use typedef for simple notation. So typedef int, okay, function prototype and the header. Again, use some of these examples and run it just for testing purposes. Use nested loops, one for row and one for columns. To visit each array element, accumulator can be used to sum the elements row by row column or over the entire array. And the accumulator is basically the sum, and maybe we'll use the array we will use. So objects can also be used in array elements. So you have a class square, then you have the variables private inside, and then you have the public part. Array objects, like an array of structures, use an array subscript to access a specific object in the array. So then use dot operator to access member methods for that object. So here would be shapes I dot get side and so forth. Initializing arrays of objects, you can use a default constructor to perform name initialization for all objects. You can use initialization list to supply specific initial values for each object. So here you have a square shapes 5, and then you're initializing it. A default constructor is used for the remaining objects if initialization list is too short. You can initialize it like that, or you can expect for the user to enter it if you want it specific. If you wanted, let's say, to give the user a choice. If an object is initialized with a constructor that takes greater than one argument, more than one argument, then the initialization list must include a call to the constructor for that object. Right? So you have 3, 2, 5, 1, 3, whatever the rectangle dimension is. The structure can be used as arrays of structures. Structures can be used as an array element. So here you have a struct student, and then you define your variables there, and then you say the size, and then the class size. So this holds 30 students. Again, you can have that in there instead. So use array subscripts to access a specific structure in an array, then use the dot operator to access members of that structure for each one of these. All right. So let's do a quick array declaration. So let's say int numbers, and then when we declare it, we have to use the bracket. And let's say we also want total of this. Okay, let's say integer total and initialize it to 0 because we don't know how many originally, right? We don't have anything. Instead of just declaring an empty one, let's say we want to find a total of 5 numbers. Okay. So let's ask the question. Fish enter 5 numbers. So you want the user to enter 5 numbers, right? Then we can write a loop for this, and then say for integer I equal to 0, we initialize it to 0, and say I less than, we have 5 elements, less than 5, and we want to increment to that. And here, we want to read what the user enters, right? So we called it numbers. So we want to read each element that they enter, right? After that, we can say sum plus whatever number it is, or we can do augmented operator and then say numbers I. And so we want to add the numbers that we get from there. And then we also want to print that. So this would be cout, and then say the total is say sum all right, so let's run it. Did I use the variable sum or total? So if I use total here, that means I need to use total here, right? And if I'm using total, then I need to use total here, just to be consistent. So now it says enter 5 numbers. 1, 2, 3, 4, 5. And then it will say the total is 15. And you can enter it as, you know, just 1, and then enter 2, enter 3, enter 4, enter 5, enter. And we'll say the total is 15. So we have the array declared, and then we also want to do the total, and we set it 0. And then we're asking the user to enter 5 numbers, and then we have to do a loop so that the user enters that, and then you can say see out the total is. And we can even do what's called average. All right, if you wanted to do that, or here, like kind of like integer, and then say size, and then print that also. If you wanted to do the average, so it will be the total divided by the number side. That's another way of doing the average. And again, that's why you have all those examples in there. Just try to run it and practice.